Alright, so in the last video, you learned about rational functions and there being different kinds. There being continuous and discontinuous, and that there's points at which those graphs are discontinuous. Alright, so you received this paper in class. This is the Holy Grail. This is everything that you're going to need to know in order to identify the key parts of rational functions. So do not lose this paper. It's the most important one by far. So I'm going to go step by step through each one. Each video is going to be a different one, and this one's going to be about the domain. The domain is always all real numbers except for what makes the denominator 0. So there's something that's going to make the denominator 0, because remember, 0 is not allowed to be in the denominator. So the domain, all the possible x values, is everything except for what makes the denominator 0. So I'm going to go problem by problem. So the first one is right here. Okay? So first thing that you need to do every single time, even before you do the domain, is you need to factor. So you want to write that at the top, factor first. Okay, so I'll write it a little bit bigger. Okay? So the first thing you need to do is factor. So this denominator can actually be factored. Okay? So if I factor it, what factors to 3 add up to 4? It's 3 and 1, so x plus 3 times x plus 1. Okay, so that's our factor form. So now we can talk about the domain. So the domain is always all real numbers except for what makes the denominator 0. So that all real numbers part, this part right here, all real numbers. Okay, there's actually a symbol in math, and it's just an R with a line going through it. All real numbers. And then as it says on our little paper right here, x cannot equal. So it's all numbers, but x is not allowed to equal what? What value could I plug in here that would make the denominator, that would make this part 0? So if I plugged in -3, -3 plus 3 is 0, so I'm not allowed to have -3. Okay? What about this one? What would make this? What value could I plug in for x that would make the denominator 0? What would make this be equal to 0? And that would be -1. Okay, the trick is to just switch the sign. So -3 plus 3 is 0. -1 plus 1 is 0. So x can be any number except for -3 and -1, because it would make the denominator 0, and we can't have the denominator be 0. Okay, so now let's look at question B. Okay, question B, the denominator cannot be factored. So our denominator is x squared plus 1. So what makes that equal to 0? So you think, all right, the shortcut she just said, just switch the sign. Well, the opposite of 1 is -1. Well, -1 squared is +1. +1 plus 1 is 2. So this is actually a tricky problem because there's nothing that makes the denominator 0. So again, the domain is always all real numbers. So I'm going to put my symbol, my R with the line going through it, all real numbers except for what makes the denominator 0. Now nothing is going to make this denominator 0, so the domain for this one is just all real numbers. Okay. Now we have letter C. Okay. This one, the numerator can actually be factored. X minus 4 times x plus 1 over x minus 4. Okay. Now, the denominator, or the domain, is all real numbers except for what makes the denominator 0. So we're just looking at the denominator. So what would make this be 0? So again, the little trick, just change the sign. Opposite of -4 is 4. Think about it. 4 minus 4 is 0. So the domain is all real numbers except x cannot be 4, because that would make the denominator 0. Okay. Now if we look at the U-try problem, what you should do is you should pause the video and then see if you can do it on your own. Okay, so pause it now. So if I factor first, this is the difference of perfect squares. Okay. What would make the denominator 0? First of all, it's all real numbers. And then x cannot equal. What would make this 0 would be +4. And what would make this one 0 would be -4. Okay, so those are all of our problems up until now. How to find the domain. Remember, it's just all real numbers except for what makes the denominator 0.